In this video, I'm going to show you how to use this general annuity calculator. If you're watching this video on YouTube, you can go down to the description box below and you can see this URL here. You copy it. Okay, let's copy it. And then paste it to a new window. And then click. And it leads you to the Google Drive file. And once it's ready, you click the file here on the left corner, upper left corner, and you have this drop down menu. Go to the download and then make sure you have this format, Microsoft Excel XLSX. Okay, once you click this, the file will be downloaded, and once it's downloaded, you can then open it and you have this calculator. And once you have this calculator, then we can now start using it. And how to use this calculator? Okay, well, let's apply that to this problem. By the way, the calculator has actually there are two calculators here using the two formulas for finding the general annuity calculator. So this formula here is the simple one. It looks like the simple annuity formula where the I is changed to J. In my previous video, I explained how the J uh, comes from. Okay, and this one is the longer computation formula, and we can solve it using this calculator here. Okay, let's apply it to this problem over here. We have Mrs. Patricia worked very hard for retirement for a public school teacher. She wants to withdraw 62,500 every 3 months for 12 years. How much does she deposit retirement of 15% per year compounded semi-annually? Now let's look at the compounding period semi-annually, and the interval of payment is 3 months, so they don't match. This is a general annuity problem. And let's try to use this number one formula first. Okay, let's key in the values in a given. The 62,500, that is the cash flow that she's going to receive in the future. So we'll write that here as the for R, the 62,500, and then she will receive this every 3 months for 12 years. So the time is 12 for the span of 12 years. And then the percentage is 15%. That is 0.15 compounded semi-annually. So that's twice a year. Now we put this in our M2, the original compounding period. So that is twice a year. And then the M1 is the compounding period that is adjusted so that it will match to the payment interval, that is 3 months. Okay, so we'll change this semi-annually into quarterly. 3 months is quarterly. So quarterly is 4 times a year. So our M1 is 4. Okay, I think all the values are already put down here, and we have the value of our J. The J comes from this formula. Okay, and then we're actually looking for the present value. Okay, this is the amount that she needs to produce. Okay, so that she will receive the 62,500 in the future every 3 months. Now let's check the consistencies of this formula. Say we want to know if this is really correct. Now if you look at it, this is the compounding interest with compounding interest from the compounding interest formula, and if you notice, this is the amount and this is the principal, and if you see, the amount is relative to the future value, and in fact they are the same, right? And then the principal is to the present value. In fact, the annuity formula descended from the compounding interest. So they all come from the compounding interest formula. Okay, now let's copy this one, the present value. Let's copy that and paste it here to check if our answer is correct, to check if we get the regular payments correctly. Okay, when you paste it, make sure you go to this 1, 2, 3 option. Okay, so that you paste only the value. And what we have here in the regular payments is 62,500. So we go back to the original value. Now for the future, we'll copy that and paste it to the future value. And 1, 2, 3 again. Again, we got the same value for our regular payments for the future value. Okay, so that means our formula is consistent. Calculator is consistent. Now let's go to the second formula. This one is the longer one. So let's list down our R, capital R, which is 62,500. And then the time is the same, 12 for 12 years. Next is the M. The M is the original, the M2, the original value, which is semi-annually. That is twice a year, so that's 2. And then what else? The percentage is 0.15. Okay. And then what else? We have the P. The P is the number of months of the interval of payment. So what is the number of months? The problem here is every 3 months. Okay, every 3 months. So this is 3. And then the C is the number of months for the compounding period, compounded semi-annually. So that is 6. Right. That is 6. And then enter. Oh, let's check the value here. Oh, this is now our. What else do we need? Oh, we haven't got the C correctly. What's our C again? Our C is semi-annually, so that is 6 months. Wait, 6 months. What is our P? Our P is 3 months. Okay, P is 3 months. P is the number of months for the interval of payments. Okay, and C is the number of months for the compounding period. Okay, let's check our answer. So the present value here, if we look at it, compare it to the first formula, they're the same. The future value, they're also the same. I mean, if you copy this, okay, and put this to the present value here, okay, I go back to the R and the future value. Is this only for the checking to find out if our calculator is consistent? Where is it? There. Okay, so it goes back to the R, capital R, or the regular payment. So our formula is consistent. Okay, let's check another one. Let's go back to, let's set this again to 0 to avoid confusion for our second problem. Okay, here we go. We go to number 2 problem. So Patrick paid 150,000 as down payment for a car. The remaining amount is to be settled by paying 14,500 by the end of each month for 5 years. Okay, each month. If the interest rate is 12% compounded quarterly, so they don't match. This is general annuity formula. And what is the cash price of this car? Now the cash price of this car is the present value plus the down payments. That's very easy to understand. Okay, let's list down all the given in the problem. So the remaining amount is to be paid, settled down by paying 14,500. So that is the R, 14,500. And then for the span of 5 years, okay. And then M2 is the original compounding number of compounding period, which is quarterly, that is 4 times a year. And then our percentage is 12%, that is 0.12. And then our M1 is the adjusted or the changed compounding period to match our uh, inter payment interval. So our payment interval is each month. So our compounding period as well must be each month here. Okay, so each month is 12. Set down 12 and then enter. Okay, so the cash price of the car is 653,000. We still have to add it to the down payment. Okay, let's copy that. 653,599.3485 plus we add it to the down payment, which is 150,000, and then oops, okay, wait. All right, so this is the value, this is the cash price of the cars, 803,599. Okay, let's go to the third problem here. So Anna would like to save 6,200 every month in a cooperative group that gives 5.5% interest compounded quarterly. So the interval of payments is every month, and then compounding period is quarterly. So it's a general annuity problem. And how much is the amount of the future value for savings after 6 months? So we're looking for the future value given the regular payment is 6,200. Let's set all this to 0 first, okay, to avoid confusion. Now the regular payment is 6,200, and then the interest rate is 5.5% is 0.055, and then the time is 6 months, or the whole payment 6 months is 0.5 year. Okay, M2, the original number of compounding period, is quarterly. Quarterly, that's 4 times a year. And then our M1, we have to change this quarterly to that match to the payment interval, which is every month. So we'll change this monthly, and monthly is 12. Okay, and there you go, everything set. And the future value will be this one, 37,626. Okay, let's check this again for consistencies. The future value, let's check if it goes back to the, okay, it goes back to the original given, which is 6,200. Now let's use the second formula. Let's check it out. First, we have our future, our R, which is 6,200. And then we have our interest rate, which is 0.055. Our M is the original number of compounding period here, which is, where's the problem here? Here's the problem. Okay, quarterly. Quarterly is 4 times a year. Okay, and the time is the same, 0.5 a year. 6 months is 0.5 a year. And then the P here is the number of months for the payment interval. So the payment interval is every month. So that is 1. And then the C is the number of months for the compounding period, which is quarterly. That is 3 months. Quarterly is 3 months. Okay, and press enter. And we have here our future value, which is exactly the same as the first formula. So hence this calculator is consistent.